Hi, welcome back to my channel. Today we continue Physics Form 4 KSSM, Chapter 2 Forces and Motion 1 on topic 2.1 Linear Motion, Part 1. When we talk about linear motion, the word linear means straight line. So linear motion is a motion in a straight line. So when we discuss about linear motion, we want to analyze motion in terms of distance, displacement, speed, velocity, and acceleration. So you must be able to define all the important terms: distance, displacement, speed, velocity, and acceleration. Let's discuss the first part. We want to differentiate between distance and displacement. So distance refers to the total length of path travel irrespective of the direction of the motion, meaning no need to take into account the direction. Or also we can state as distance travel is total length of path travel by an object. So distance travel, it is a scalar quantity. The SI unit is meter. Other common unit used is kilometer or centimeter. So when we talk about displacement, displacement refers to distance moved in a particular direction or distance travel in a specified direction. So we need to consider direction when we discuss about displacement, because displacement is a vector quantity. SI unit, same as distance, meter. Other common unit used, kilometer and centimeter. Now let's look at one example. A student walks 4 meters east, meaning A to B, 2 meters south, meaning B to C, and then 4 meters west from C to D, and finally 2 meters north, meaning D to A. So the initial position or initial point of the student is at A, meaning at the end, the student go back to the initial position or return to original position. Now we want to determine what is distance traveled by the student, what is displacement of the student. So the distance traveled we have discussed as total length of path travel. No need to take into account the direction, we just total up. So for distance travel equals to AB plus BC plus CD plus DA, or 4 plus 2 plus 4 plus 2, so we get 12 meters. So the distance traveled by the student is 12 meters. Now we look at displacement. Displacement is the distance moved in particular direction, or the shortest distance traveled by the student from initial point to final point. Now if you look at carefully this situation, the student start from A and then return to its original position, meaning no change in position at the end. So no change in change in position, meaning displacement equals to 0. So in this case, the student back to original position. Okay. Okay, next we want to discuss about speed and velocity. What is the meaning of speed? Speed is rate of change of distance. You look at the formula here. The word rate refers to per unit time or divide by time. So rate of change of distance, meaning distance traveled divided by time taken. And the speed is scalar quantity. Now we look at velocity. Velocity is the distance traveled in a specific direction. It is also defined as the rate of change of displacement. So look at the formula here, meaning velocity equals to change in displacement divided by time taken. So velocity is vector quantity. If you look at carefully, displacement is vector. So this one will cause velocity to become vector. For speed, distance is scalar, and the time of course is scalar. The speed will become scalar quantity. Okay, next, instantaneous speed and average speed. But as an object moves, it often undergoes changes in speed. As you can see in the car, you can observe the value of speed shown by the pointer or speedometer. Okay, this one is speedometer. The speed at any instant is known as instantaneous speed from the value of speedometer. For example, at 5:30 p.m. you look at the speedometer, show the reading is 100 or 100 kilometer per hour. So that value we call it instantaneous speed. Okay, because value at that instant, at that second only. When we talk about the speed of the entire journey, so that one we call it average speed. So average speed we can determine by using this formula: total distance traveled divided by total time taken. If you want to calculate for average velocity, meaning total displacement divided by total time taken. Okay, let's look at the same example as example 1. Now we want to determine what is the value of speed and velocity and average speed of the student walks from A to B, B to C, and C to D, then back to A. If you want to calculate speed, remember the definition for speed is rate of change of distance, meaning distance traveled divided by time taken. So now the time taken for the journey is 5 minutes. So it's equals to 12 distance travel divided by minutes, convert to second. So 300 seconds. So we get 0.04 meter per second. For velocity equals to rate of change of displacement. Thus velocity equals to 0. Displacement 0 because the student returned to original position. Okay, no change in position at the end. So displacement 0 divided by total time taken, same total time taken. So we get 0 meter per second. So velocity equals to 0. How about the average speed? So the average speed is total distance traveled divided by total time taken. So in this case, we already calculate the total distance is AB plus BC plus CD and plus DA, and then we get equals to 12. So 12 divided by total time taken 5 minutes, convert to second. So we get 0.04 meter per second. So from here, speed and average speed actually are the same. The difference is if you calculate the speed from A to B, that one is not average speed because we calculate for AB. If you have the value of time taken from A to B, meaning you can calculate the speed from A to B. The same thing, you can calculate the speed from B to C, or you can calculate the speed from C to D or D to A. Okay, but now if we discuss for the whole journey, that one will become average speed of the student. Okay, now acceleration. What is acceleration? So acceleration can be defined as rate of change of velocity. So rate of change in velocity equals to change in velocity divided by time taken. Acceleration is a vector quantity. You look at the formula here, velocity. So that's the reason why acceleration becomes vector quantity. So we have this formula. Let's say we mark A as acceleration, V is final velocity, U initial velocity, and T equals to time. Thus we get acceleration equals to V minus U divided by T. Okay, and the SI unit from here equals to meter per second squared, or meter second to the power negative 2. Okay, look at example 2. Acceleration from this diagram can be determined. So initial speed or initial velocity U here is 10 meter per second. After 20 seconds, the velocity becomes 50 meter per second. So this one will become final velocity. So now acceleration of the bird equals to acceleration of the bird A equals to 50, v minus u divided by t. So 50 minus 10 divided by 20. Thus we get 40 divided 20 equals to 2 meters second negative 2. So here we get the value of A positive, meaning the velocity increases in the direction of the bird moving. Okay. Okay, we want to analyze motion of an object. Let's say we have a car here. Okay. For the car, we can look at the speedometer reading in order to check whether the car is moving with uniform velocity or non-uniform velocity. So what is non-uniform velocity? Non-uniform velocity means maybe velocity increases or velocity decreases. Let's look at the first situation. You can look at the car at t1 equals to 0 second. After 1 second, it travels 20 meter. After another 1 second, 20 meter. Another 1 second, 20 meter. So what can you say about the type of motion of the car? So you can see the car is moving at uniform velocity because its rate of change of displacement remains the same. We have discussed earlier, velocity equals to change of displacement divided by time taken. So for the same time taken, same displacement, meaning same velocity. So this one we call it uniform velocity. Okay, second situation. So you can look at this car from initial point t1 equals to 0 second. After 1 second, it travels 20 meter. After another 1 second, it travels 30 meter, meaning the displacement increases, okay, in the same time taken. So what you can say about the motion of the car? So the rate of change of displacement increases uniformly. Same time taken, but the displacement increases. So this one will cause velocity of the car to increase. So we can say the car accelerates. So in this case, because of the velocity increases in the direction of the car moving, so the car accelerates in the same direction as the motion of the car. Or we can say positive acceleration. Okay, third situation. At t1 equals to 0 second here. After 1 second, it travels 30 meter. The next 1 second, it's only travel 20 meter, meaning the displacement decreases, okay, in a same time interval. So what we can say about the motion? So the rate of change of displacement decreases. Same time taken, but the displacement becomes smaller. So in this case, the car accelerates but in opposite direction to the motion of the car, meaning it accelerates backward. Or in other words, we can say deceleration, the car slowing down. Or we can also state as negative acceleration. So in this case, the car accelerates in opposite direction to the motion of the car. Okay. So you must be able to identify a type of motion based on the diagram given. Okay, next we want to determine distance, displacement, speed, velocity and acceleration by using a formula. We have formula stated here. To determine the speed, definition we have discussed earlier, speed equals to distance traveled divided by time taken, or speed equals to rate of change of distance traveled. So distance traveled we mark as d, small d. So the speed equals to d divided by t. For velocity, defined as rate of change of displacement, so equals to displacement divided by time taken. So velocity equals to displacement we mark as s. So v equals to s divided by t. So now we can see the difference between speed and velocity. For acceleration, defined as rate of change of velocity, so meaning final velocity minus initial velocity divided by time taken for change of velocity, meaning from initial to final, what is the time taken? Okay, so all we can state in the formula, A equals V minus U divided by T. So we will discuss later on the problem solving by using the formula. Okay, now look at example 1 here. Figure 2.6 shows Razis run from A to B and then back to C. A to B and then back to C. The total time taken is 20 seconds. Determine distance and displacement. So remember the definition for distance, total length of path travel. And this one is scalar. Displacement is the distance traveled in specified direction or the shortest distance traveled from initial point to final point. Okay, so A, distance equals to length of route covered or length of path travel. So AB plus BC. Okay, so straight away we just total up. So 100 plus 20 is 120 meter. Okay, now displacement, distance between initial point and final point in a specific direction. So this is the initial point, this is the final point. So what is the distance travel here? This one is displacement. Okay, so you just take 100 minus 20 meter. Why we need to minus actually? Because BC is opposite direction to the initial position or initial motion. Okay, so AB plus BC, so we get 100 minus 20. So we get the value is positive, meaning displacement is directed towards the right. Okay, because displacement is vector. Okay, example 2. Motor move from O to B along route OAB. OAB. Okay, the time taken 15 seconds. Determine distance, displacement, speed, velocity of motor's motion. So you can see the first one, distance, total length of route travel. So what is the total length of route? You must know where is the initial point, where is the final point. So this is initial, this is final. Okay, so the total route of path travel is OA plus AB. So 5 plus 12. So we get 17 meter. Displacement equals to distance or the shortest distance from initial to final, meaning OB. So from here you can just draw a straight line connecting O and B, initial and final point. And then you can use a mathematical operation to find length of B. So the shortest straight line distance from O to B, OB equals to square root of, this is Pythagoras theorem. So 5 square plus 12 square. So we get 13 meter. Which direction? O to B. Okay, so displacement of motor. Okay, next. If you want to determine speed, you just straight away can use the formula of speed, distance divided by time taken. So distance is, time taken is 15. So 17 divided by 15. So you can get the speed. And the velocity is displacement divided by time taken, meaning 13 meter divided by 15 seconds. That one you can try yourself, how to calculate speed and velocity. Okay, next example 3. After landing on a runway, a plane slows down so that its velocity reduces from 75 to 5 meters per second in 20 seconds. What is the acceleration of the plane? So if you read through the example here or other question, something like this, what you do, you just can identify all the values given and then you can list it down first. For example, U equals to 75 meter per second, V equals 5 meter per second, T equals 20 seconds. So you just list it down first. Okay, and then write the formula that you want to use. A equals V minus U divided by T. remember the formula is v minus u divided by t. So you must follow the formula. Don't take the larger one minus the smaller one. Always take v minus u. So the v here is 5. So 5 minus 75 divided by 20. So the value is negative. So we get negative 3.5 meters second, negative 2. So in this case, we can say the plane decelerate or slowing down. Or you can say also accelerate in opposite direction. Okay, so you can see the velocity decreases. Okay, so that's all for this part. So you must be able to use all the formula that we discussed in this part, and also you need to memorize a definition of important terms, something like distance, displacement, speed, velocity, average velocity, so that you will understand better. Okay, so I will stop here. So we'll discuss more in topic in my next video, part 2. Okay, bye.